Hello everyone, my name is Simon. Today I'll be taking you through a brief demo on MISLAND North Africa. MISLAND North Africa is an online land degradation monitoring system for North African countries. The system covers 5 countries, which are Tunisia, Algeria, Egypt, Libya, and Morocco. The system has 3 main sections, which are the section where you can select the region of interest, an area where you can select the parameter that you want to compute, and the map panel. To use the system, you need first to select your region of interest. For the sake of this demo, I select Tunisia, select Benja, then Nefda. After selecting the sub-region, you will notice that the system has already computed the land use land cover for the year 2018 for my region of interest. You'll also notice that we have a brief summary at the bottom. So according to the system, 50% of NEPTA was actually croplands, 41% was forest, 6% was water, and 2% was bare land. The system enables you to compute the SGG 15.31 land degradation indicators. The SDG indicators are productivity, land use land cover, and carbon stock. Note that productivity also has sub-indicators, which are a trajectory, state, and performance. To compute any of the sub-indicators, you just need to select them. For the sake of this demo, let's select the productivity since it has several sub-indicators. And then let's select the data source that we want to use. You can select MODIS or Landsat. For the purpose of this demo, let's select MODIS. Then the analysis, we want to compute trajectory. Let's select the year. It will be 2000, let's say to 2010. Now the system will compute the trajectory for the area of interest between 2000 and 2010. And the system have completed the computation. On the map panel, you can see the trajectory map. You can also see the region where we have the stable potential improvement and potential degradation. According to the chart, 81% of the region of interest remained stable during the period that was selected, which is 2000 to 2010. 18% showed potential improvement, while 1% showed potential degradation. You can also compute the other sub-indicators for productivity, which are state and performance. In addition to that, you can compute the land use land cover. You can also compute the carbon stock change, or you can compute the land degradation. Land degradation takes into account carbon stock change, land use land cover change, and productivity change of the area of interest. The other thing you can compute with the system is vegetation loss, vegetation gain. Vegetation loss gain is computed either using MODIS dataset or Landsat, and also it uses vegetation indices. You can use the NDVI, which is normalized difference vegetation index, or the survey or LEM survey. According to what we can see on the chart, around 38% of the area of interest experience vegetation gain during the period 2000 to 2010. 33% experience vegetation loss, while around 29% of the region remain relatively stable. Another parameter you can compute with the system is forest change. Forest change is computed using 2 main sources, which are land use land cover, as well as Hansen. For the sake of this demo, let's select Hansen. Then let's select a different year, let's say 2010. And let's see what the system shows us. According to the system, it seems there are some areas that actually experience forest loss during in the year 2010. Hansen uses Landsat data, which means that it has a resolution of around 30 meter by 30 meter. The system also enables you to select a polygon instead of just selecting a region. So you have a specific region that you want to analyze, you can just draw a polygon. To do this, let's just select a small region, let's say around this area. And then let's select vegetation loss. And as you can see, already we have MODIS datasets and VI 2000 to 2010 vegetation loss. In this case, we can select Landsat dataset as opposed to just MODIS dataset. MODIS dataset has a resolution of around 250 meters, while the Landsat dataset has a resolution of 30 meters. Let's select Landsat and see what difference we'll get. Kindly note that according to MODIS datasets, the vegetation loss for the region of interest was around 25%. The gain was 38%. And the stable area was also 38%. So let's select Landsat. Let's select NDVI, same period, 2000 to 2010. Let's see what we are going to get. And there you have it. As you can see that the higher resolution dataset is giving more details of the area of interest. Another thing I would like to mention is that you can always export the dataset you are seeing here. You can export the chart as an image, or you can export the dataset that have been used to create the chart. That way you can create a different chart to suit your needs. To do that, just select here, select where you want to save it, in this case in my export. So I can select this and save. And here we have the chart. You can also export the data set that was used as CSV. Let me save it in the same location. Yeah, it is. So also note that you can also compute forest fire. You can also compute forest fire with the system. We'll also be implementing medallions, which have not been implemented at this point. Also note that everything that we have done with the system so far can be done also, can also be viewed in French. To change the language of the system, just come here, select French. As you can see, it have changed, but not everything will change. You'll have to change something, let's say the year to say 2002 for it to take effect. As you can see, the system have changed. The summary is in French. The legend here is in French. So is the legend here. And so are the other things. Okay. Okay, and that's the end of my presentation today. Thanks for your attention. See you next time. Thank you.